Hello, and welcome to Math Matters. I'm Miss Ogden, and today we're going to continue exploring ratios using pictures and real-life examples. You will need paper and a pencil or something else to write with for this lesson. Please take a moment to find those materials. Take a look at the images of set A and set B on your screen. What's the same? What is different? Take a moment to write down your ideas. Let's talk about what's the same. In set A, the ratio of white dots to the total number of dots is 1 to 4. We call this a part to whole ratio. What do you notice about the ratio of white dots to the total number of dots in set B? If you said the ratio of white dots to the total number of dots in set B is 2 to 8, you're correct. If we're thinking about what's the same between sets A and B, one thing we might consider is splitting each group into 4 equal groups. If we split set A into 4 equal groups, the white dot represents 1 out of 4 equal groups. We can use that same line of thinking for set B. If we split set B into 4 equal groups, the white dots will represent 1 out of 4 equal groups too. In both set A and set B, we can represent the number of white dots to the total number of dots as the ratio 1 to 4, or one group of white dots out of 4 groups of dots. The ratio of white dots to the total dots in set A is 1 to 4. And the ratio of white dots to total dots in set B is 2 to 8. We call these ratios equivalent because the relationship of white dots to the total number of dots is the same. Let's take a moment to discuss what's different. In set A, the ratio of gray dots to the total number of dots is 1 to 4. We can also represent this relationship as a fraction, which would be 1/4. In set B, the ratio of gray dots to the total number of dots is 4 to 8. We can also represent this as a fraction, 4/8 or 1/2. The ratio of gray dots to the total number of dots in set A is 1 to 4. The ratio of gray dots to the total number of dots in set B is 4 to 8. These ratios are not equivalent. The relationship of gray dots to the total number of dots in set A and set B are not the same because 1/4 is not equal to 1/2. Now let's explore some ratios in real life. We use ratios when we bake all the time. Let's read about Alex's bake sale. Alex is making chocolate chip cookies. She needs 2 cups of flour for each batch of cookies that she makes. Alex would like to make 3 batches of chocolate chip cookies for her school's bake sale. How much flour will she need? Take a moment to think through how you might solve this problem, then give it a try. You can use pictures, words, a table, or numbers to show your thinking. One way mathematicians might choose to show their thinking is by drawing a picture. What do you notice? What is the relationship between the cups of flour and the batches of cookies? How could you use this picture to find the amount of flour needed for 4 batches of cookies? If we keep drawing pictures to extend this relationship, we can see that Alex will need 8 cups of flour to make 4 batches of cookies. In the previous example, we discussed the idea of equivalent ratios. Let's use the picture on the next slide to find some more equivalent ratios. Here we can see that Alex needs 2 cups of flour to make 1 batch of cookies. This relationship stays constant as we find the amount of flour needed for Alex to make 4 batches of cookies. The ratio in this scenario is 2 cups to 1 batch of cookies. So if Alex were to make 4 batches of cookies, the ratio would be 8 cups of flour to 4 batches. In today's episode of Math Matters, we learned about using pictures and real-world scenarios to think about equivalent ratios. Can you create a picture of a ratio? Can you find ratios that you use in your everyday life? I'm Miss Ogden. I hope you have a great day and keep on counting.